Today, we are privileged to speak with Professor Kanak Saha, an eminent astrophysicist at the Inter-University Center for Astronomy and Astrophysics, IUCCA. He specializes in the dynamics and evolution of galaxies and is the recipient of the Shanti Swarup Bhatnagar Prize for his discovery of the faint galaxy AUDFS01, which sheds light on how the dark ages of the universe ended. Professor Saha also serves as the Northeast India coordinator for IUCCA's Northeast Meet of Astronomers, encouraging students and researchers in the region to collaborate and explore astronomy. Welcome to the program, Professor. To start with you are an astrophysicist at Inter-University Center for Astronomy and Astrophysics, IUCCA. Can you tell us a little about IUCCA, like what it is and what does it do?
Well, thank you for having me. It's a great privilege to be here. In short, the IUCCA, as we call it, IUCCA. IUCCA is a premier astrophysics institute in the country. You can think about it as an excellent world-class school to do research in astrophysics and cosmology. It was founded in 1988 by the University Grants Commission, Government of India, and it was founded by Professor Jayant Vishnu Narlikar, and he was the founding director of this institute, along with two co-founders and former directors of IUCCA, Professor Naresh Dadhish and Professor Kembavi. It was established in that time with a motto to nucleate, to encourage astrophysics research in the country, especially in the university sectors. IUCCA is like a centralized facility with resources like access to telescope observation, you have the data, the scientific computing, like mentoring, like everyone could use. So it's like the faculties, the students, they could come to our institute and discuss about the astrophysics problem with any of us, and develop a research program that they wish to. So and then we have now a very ever growing list of these astronomers from the universities who connects to IUCCA, through his various programs.
The Inter-University Center for Astronomy and Astrophysics is one of the initiators of the Northeast Meet of Astronomers in the region, and you are the Northeast India's IUCCA coordinator of the meet. So tell us, what is Northeast Meet of Astronomers and what significance does it hold for the region?
Well, Northeast Meet of Astronomers, in short we call it NEMA, and NEMA is a unique sort of platform where young astronomers from this region, from all the states of the Northeast region, they come to this platform, to this meeting, and present their excitement in the new findings about astronomical research in this platform. And they also it helps networking between different parts. There will be astronomers coming from Manipur to Arunachal, or from Assam to Arunachal, like this. So it helps building an interconnectivity. So this networking is is very crucial for developing their future career and to grow as an excellent astronomers and over time.
Does it happen annually or?
Yeah, it happens every year, and in Arunachal, that is the RGU, that's going to happen. This is the 11th time. So it's already 10th NEMA is passed, and we are at the 11th edition of the NEMA, and this year. And in general, it is funded more or less by IUCCA with the support from the universities. Each year there will be a host, rather this time RGU Arunachal Pradesh is the host, and they provide local support, and then IUCCA provides the rest of the funding to have this meeting, mostly through the traveling of this travel support for the students and some others.
The aim of the meet is to encourage young students, researchers, colleges, and universities in the region working on this field to bring on a single platform to stimulate discussion and collaborations. Well, since the beginning, as it's the 11th year now, do you think this initiative is a success? and how?
I would say that this is a success story. This is a very I think effective meeting. I remember in the first or the second edition, the number of participants they were probably less than 40 or less, and now it has grown more than 100. So in 10 years, it's a slow development, but I think it's ever growing. And we have to, because of the resource limitation, we had to actually cut down on the number of participants. So I think there is a growing popularity. So,
Sir, like this meet, what other ways can there be that would encourage the students in the grassroots levels to have interest towards this field?
So to do that, that's why we thought we have spent a decade of doing the NEMA meeting in this, as I said, this is 11th year, and we thought, okay, why don't we think about something like new addition, new side activity? So we wanted to have something called the pre-NEMA activity, and as one of the element of the pre-NEMA activity was this night sky watching session that we wanted to reach out to the students of Arunachal Pradesh and their parents, and then who could come and look through the telescope and look at the planets, the stars, and I hope I thought that would bring some excitement to the young minds.
It is believed that the universe is formed after the Big Bang from singularity, and this development has been divided into various phases. Can you tell us more about Big Bang in simple language so that our listeners can understand?
Well, the Big Bang is a scientific explanation for how the universe began. It does not mean that there was an explosion in space. It means that the space itself started expanding from a very tiny, hot, and incredibly dense phase. Okay, about 13.8 billion years ago. You can think about this like universe is like a balloon. At the beginning, the balloon was very tiny, super tiny, and it started inflating very fast. Okay, and then everything in the universe, like stars, galaxies, planets, they formed as the balloon expanded. That's how we see as what we see as the Big Bang.
Sir, you have worked and is working on the dynamics and evolution of galaxies. Among your achievements is the discovery of one of the earliest galaxies emitting extreme ultraviolet lights, named as AUDFS01. The discovery was made by India's first multi-wavelength satellite, AstroSat. This discovery is said to be a very important clue to how the dark ages of the universe ended and there was light in the universe. Can you tell us more about it? And how is your discovery going to contribute to our understanding about the universe and its formation?
Well, this discovery, which was done using India's first space observatory and ultraviolet imaging telescope on AstroSat, this discovery sort of matters because it provides a piece of puzzle in understanding how the early universe lit up, okay, and how the hydrogen gas in the universe ionized for the second time. It's so it connects to an important phase of the universe. It's called the reionization phase. Okay, at the very beginning, like when the universe was just 400,000 years old, that time there was mostly like neutral hydrogen gas in the universe. There were no stars, there was no galaxy formed. And then these first stars started forming, and then first galaxies started forming. And when the first stars and first galaxies formed, they emit a lot of high energy photons, UV photons, extreme UV photons. These photons, when they come out of this galaxy, they start ionizing hydrogen atoms. Okay, and that's how the reionization process started. Now the trouble is that we cannot detect or cannot observe that what type of galaxies did this process. The discovery of this AUDFS01 is a concrete example of such a galaxy. So that's how I think it helps sort of understanding. But there is a long way to go as well, because this galaxy is at a nearby universe. Not exactly when the reionization happened, but when reionization happened, we do not have direct observation. So we depend on indirect ways. We wanted to know what kind of galaxies were they. So this AUDFA01 is an example of such a galaxy.
Is there more work done towards that?
Yes. So what we want to do is basically we like to go exactly when directly observe those galaxies. So push the limit as far as we can. And currently, I think a lot of astronomers are sort of finding ways to observe those galaxies. So it's an active, very, very active field, project.
The next question is about the telescope. The James Webb Space Telescope is now looking deeper into the space than ever before, even spotting galaxies just a few 100 million years after the Big Bang. How do you see these new discoveries of the James Webb Space Telescope, JWST? Is it challenging existing mankind's concepts about the universe, or is it refining these centuries-long researches of the scientific community?
It is true that JWST, the James Webb, is bringing us a lot of surprise because we know now galaxies just when the universe was just 300 to 400 million years old. And these galaxies that the James Webb is observing or finding, they seem to be quite massive and evolved. And if it is true, means that if they are really massive and then really evolved, then that may bring us a challenge. We may need to rethink about how the astrophysics of galaxy formation works. However, the finding galaxies at this early was not a surprise, because the standard models of galaxy formation, we expect galaxies to be formed at that time, between when the universe was 300 to 500 million years old. The only issue is basically is that whether they're really massive, because we expect the galaxies, the theory predicts that the galaxies should have been like tiny, low mass, small. It's like if you are trying to trace ourselves back in time, we would be expecting like a baby when we were born. Similarly, we see the galaxies today like big, massive galaxy, very, very heavy, right? And if we trace back in time, we expect them to be small, young, but we see them like massive and being as if we are seeing a grown-up person at the birthplace itself. So that's kind of surprising. But I think these challenges should not be a panic, but it should be considered as a sign of progress. So we are not in a crisis. We are in a refinement and recalibration phase. We need to constantly refine ourselves and recalibrate, and then to help understand such discoveries. Yeah, so it's as I said, this is not a threat. It may not break the cosmology, but it will push us to revise, refinement, recalibration. That is what is pushing us to do.
So how does the study of galaxies, stars, and celestial objects help in the evolution of human life? And why should ordinary people like us should care about the galaxies so far away from us?
Yeah, so to answer this question, I would say that every person, every life on Earth that lives is in one galaxy. That's the Milky Way. That's our home galaxy. So you can think about galaxies are like countries in the universe. Okay, and studying the galaxy is like studying our cosmic home. Of course, we live on Earth. Then the Earth lives in solar system. The solar system itself in the Milky Way galaxy, and that's our cosmic home. So, in this sense, I would say that it's deeply should motivate the human beings to study our cosmic home. Okay, and if you think about why should ordinary people care about studying galaxies, first of all, my answer would be like, this is your cosmic home. Who doesn't want to know your home, right? So that's the one thing. And it's like if you think in other ways, is that the lives on Earth are like made up of fundamental elements, like the materials. They are like carbon, nitrogen, oxygen, like all of these elements are actually produced in stars. We come from sun, but the stars are produced in the galaxy. So the young stars are born always in the galaxies. So we are deeply connected to the galaxy in this way. It's like and if you think of it other ways, in other direction, like it could be also like a pure curiosity, right? The pure curiosity is the driver of progress, right? I mean, by studying galaxies, we may not instantly gain some technology, but for example, if you here is a radio astronomy, gave rise to Wi-Fi, GPS, okay, CCDs detectors were actually for astronomy, optical astronomy, and that is used in your smartphone nowadays. The advanced data analysis that we do in astronomy, right? Finding a needle in the haystack, such a faint signal that we want to find far away in the universe, like that advanced data analysis now is going to be machine learning techniques, they are there. So you can immediately see that these are all designed to study celestial objects and the galaxy so far away from us. So that's the way I would say that you can connect if you care about. And so one can think about also galaxies are like a giant experimental lab which we cannot build on Earth. This is where we can test whether there is dark matter, the black hole physics, the chemical evolution. So there are how stars are formed, right? So which we cannot replicate on Earth. So we must have a laboratory. This is our cosmic laboratory. Galaxy is our cosmic laboratory where we can study and answer all these questions.
So, sir, lastly, if anyone is interested in astronomy and astrophysics among our listeners, what would you like to say to them from your side?
Astronomy is a multidisciplinary subject. Today, I think if you have a knowledge of physics, mathematics, chemistry, engineering, data analyst, computer scientist, it's like we need every one of them, and then this is a large conglomerate of this the subjects. Each of these subjects can play a very significant role in developing instruments. For example, James Webb Telescope is a state-of-the-art technology. So this technology building is very, very important. But more than that, I think the astronomy is where it allows you to nurturing the curious minds, who wants to know our universe, where we came from, and what's the fate of our universe, and to understand the working of the universe, how things work. So it gives you the way to connect to the cosmos.
Thank you so much, Professor Kanak Saha, for giving us your valuable time and sharing us about astronomy and astrophysics with our listeners and with us. Thank you so much.
Thank you very much.